Okay, Lecture 1, Chem 1060. Now at the start of most of the lectures there's going to be a list of terms that you should know. You should know their definitions. If I'm teaching the course, and there are other instructors who might use these videos, but if I'm teaching the course, I just expect you to know the definitions well enough to be able to distinguish between a set of definitions and their terms, like in a matching type of problem, or I might give the definition and leave off the defined term. So know the definitions well enough to be able to fill in that term, something along that line. But I never will ask you to state the definition of inorganic chemistry, just verbatim. So you know those definitions, but I'm not going to talk about them in the lecture. That'd be a waste of time. You have them in your textbook, learn them. That's pretty much all there is to it. I want to focus on these more difficult problems. And anything that's on in this lecture is fair game for the exam. So this is a very good review for the exam. Let's look at the first problem. Show the 4 types of bonding a carbon atom can normally have. So as I solve the problems, I usually bring up a lot of the theory as we go. So, but everything that I do on these lectures, or most of what I do in the lecture, is give you problems that are going to be very similar to the ones on the exam. So, 4 types of bonding. Carbon will always have 4 bonds to it. It can be 4 single bonds, like this. Or it can be 1 double bond and 2 single bonds. So 2 single, let's see, put single and 1 double bond. See, it's still 4 bonds. A double bond just means that a single bond means there's 2 electrons in the bond. A double bond means that there's 4. So we draw 2 lines, but you can see there's still 4 lines to it. We can have 2 double bonds. So I'm not showing a whole molecule, just showing the bonding, and that's something I might ask on the exam, is to do that. You can certainly, on my exams, you could also give an example if you wanted to show like this. This would be CO2. You could show that kind of bonding. It's up to you, but just need to show that kind of bonding. And then the last one is a single bond and a triple bond. But notice there's 4 lines always to these. So as an example, if you see this, methane, that makes sense. That's certainly a possibility. If you see this, there's something wrong here. There's not a 4th bond. It's incomplete, or there's something else going on. Now at a higher level, if you've taken organic chemistry or seen something along that line, you might see a species like this, but it's very, very unstable. We're talking about stable molecules here. So if you see this, you'd have to question it. What's going on? There's something that's missing. So there's always going to be 4 lines to each carbon. And as you go along, you'll see a big molecule, and even if there's 1 carbon that has only 3 lines to it or 2 lines to it, you'll spot it instantly because you'll recognize that is always the case. There has to be 4 lines to it. So it's a good thing to do, especially when you're writing your own structures on the exams, to go back through and make sure that each carbon has the 4 lines to it. Okay, second problem here. Draw the structure of 2 hydrocarbons, 2 hydrocarbon derivatives, 2 saturated hydrocarbons, and 2 unsaturated hydrocarbons. So this is just free to make anything that you want here. I'm going to do the 2 hydrocarbons. A hydrocarbon contains carbon and hydrogen. That's all it contains. So that's my one, so we'll just put HC here for hydrocarbon. Now I can do something like this, where we have a different bonding scheme. And just going back to that first problem, know this carbon here, 1, 2, 3, 4. This carbon, 1, 2, 3, 4. This carbon, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So, and I wouldn't make that mistake. I might initially, when I draw it, when I look at it, I could tell, and you will be able to do it too, that if there's any mistake in the bonding. Like for instance, if I had 5 bonds to this carbon, I'd be stopped in my tracks. And the more you do this, the easier it will be to see that kind of mistake. So anything that contains just carbon and hydrogen are hydrocarbons. And then they want hydrocarbon derivatives. Hydrocarbon derivative is a hydrocarbon where one of the hydrogens, one or more of the hydrogens, has been replaced with something other some other atom. So that's a hydrocarbon derivative there. Here's another one. I could have this. So this is starting out, it's nice hydrocarbon, then all of a sudden, oh, there's an oxygen. So that's no longer a hydrocarbon, because it, by definition, has to contain only carbon and hydrogen. If you put anything else in it, any other atom in there, then it's a hydrocarbon derivative. Two saturated hydrocarbons. So put saturated hydrocarbon. Making myself a little more work than and might sometimes seem like this is a little sloppy in the drawing. I'll try to slow down, but I'm writing at a very odd angle so that I can have the camera right above the page. So sometimes it'll seem like I'm having a really hard time with the drawing. So, but that's why. So here's two. Actually, they're the same molecule. This one has just been bent. So to make it a different one, we'll make this. Say this is C. Just so that they're different. But they just they're saturated because there's only single bonds that are present. An unsaturated hydrocarbon. Two examples of that. Do a really simple one, ethylene. There's a double bond there. And then we can do something like this. Oops. That's a triple bond. And notice that carbon in the center doesn't have any hydrogens to it at all because it has 4 bonds already. So here's a double bond and a triple bond. They're both unsaturated. If there's even one multiple bond present, then it's unsaturated. Okay, so we move fast, and if there's any question, there's really not much more that I can say to any of those things, just really quick bits of information. But if it seems like I missed something, go back first and replay it. Make sure that it wasn't just that I was talking a little fast the first time. Go back and replay it over and over. The students, I've done these videos for years, and that's one of the benefits, is that you can watch a problem over and over again. And sometimes it's not that there's anything wrong with the problem. It's not that I approached it incorrectly or I gave you an explanation that was wrong. It's just that it's a lot of information. So go back and try it again. If you go back a couple of times and don't get it, email me or whoever the instructor is. And but that's one of the really great things about these videos, is that you can go back and try them again. Let's see. So 3, draw the expanded structure, expanded structural formula, condensed structural formula, and skeletal structural formula. And you can also say the expanded structure, the condensed structure, the skeletal structure. There's, I should mention this point, that organic chemistry, I think the problem with it as far as students' understanding is there's so many ways of doing the same thing. In 1050 or 1170, we talk about formulas, and it has one formula. It doesn't have, we don't often talk about expanding it out, having the expanded structural formula, the condensed, the skeletal. There's line angle formulas we're going to talk about in the probably next couple of lectures. So let's look here. We have methane, and in 1050, this is how we draw methane to CH4. But in organic chemistry, the bonding can be very important, so sometimes we have to expand it out. So this is the expanded structural formula. So this is the molecular formula, expanded formula. Now the condensed, that just goes back into the regular molecular formula. When there's only one carbon, there's not much going on here. So these look exactly the same. As we go down, you'll see more of these. And then the skeletal structure, there's really not anything that we can do with this. Well, actually, no, there is. We can just write the carbon. Sorry about that. It's very odd to start with methane, but then we have C2H6, that's ethane. They're unbranched, so we just keep adding carbons in a line. So ethane, the expanded one, you can see this takes the most time. A lot of carbons here. The condensed formula, let me make sure that I'm where we should be in the book here. Yep. So this is CH3. This bond here is this bond. And instead of showing the entire, all of the hydrogens, how they're bonded, we just see this carbon is connected to 3 hydrogens, so we call it CH3. Now, you say, well, if you're doing that, why not just make C2H6? Well, the problem is we get to to larger hydrocarbons, more carbons, more hydrogens, different molecules can have the same formula. So this one, there's really nothing else that this could be besides ethane. But you'll see as we go along that we get to a point where there's even completely different kinds of molecules have the same formula. So we need we don't want to simplify it so much that we lose all information, but yet we might not want to expand it out so much that it takes 25 minutes to draw something that has, say, 12 carbons. And then the skeletal structure is this. For skeletal structures, sometimes it's nice to just do it because you're only interested in that carbon backbone. It's rare that you get to use that, and on my exams I'd point out when you can and when you can't. Because a lot of times students will use the skeletal structure as a shortcut, and that leaves off the information that I was after. So you can use it sometimes, you just have to be careful that you're allowed to. Each of these structures have specific uses to an organic chemist, when they can be used and when they can't. Now, see, this carbon here is connected to 3 hydrogens, so we call it CH3, and then that carbon is bonded, so each of these bonds that are shown in the condensed structural formula is the bond from carbon to carbon. You see we have CH2 in the center here, so we call it CH2. We condense it to CH2 and then CH3. So you can see that what we've done is we've taken the ethane, kind of pried apart this bond and put a CH2 in the middle. And we're going to see that trend continue, that pattern go on. So then we'll go to C4H8. And you might say, well, what about, you can have carbon in rings, but that's not what we're after here. We can certainly, we have cyclobutane, but I just want to show the unbranched alkanes. That's our starting point for all the naming and the structures that we're going to build throughout the next, I think it's 6 chapters. And again, the reason I want to do this out is, I guess, mainly to torture myself, but also to show you that we don't want to do this. You don't want to. A lot of students say once they do the expanded formula, that's as far as they want to go. And I forced them into doing the condensed formula and then even a more simplified form called the line angle formula, because it is just a bear to do this over and over. But I want to show everything once here. And I'm going to go faster just so that, because I think you get the basic idea. And actually, I said all 10, but running out of paper. But you can see that you just keep going, and as you add in more carbons, you put CH3 on the end. It's always going to be CH3s on the end, CH2, 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 CH2. And then the skeletal form would be just C, C, C. And they don't have to be in a straight line. They could be, you can do this if you want. Normally you don't, unless you're trying to show something with that structure, but I think we'll stop with the 5. This is methane, ethane, propane, butane, pentane, and then C6H14 is hexane, then you have heptane, octane, nonane, and decane. And you need to know those names and those formulas and all of these formulas here. If there's I thought sometimes when I put up a problem it seems like a good idea, but to draw out the rest of them is going to take like another 7-8 minutes, and I want to keep all of these videos under 20 minutes. So if I ever do this and you say, oh man, I really need to see that expanded hexane, let me know. Just let me know, or your instructor know, and go through them. They have quite a bit of it in your textbook as well, but I think we'll stop there. The pattern is there. If you have any questions, though, please let me know.